Hi, welcome back to the Dore Woodman YouTube channel. I'm Jason, as always. And this week, as you can probably tell, we're going to talk a little bit about these Mitsubishi Ecodans. These air source heat pumps are very, very popular. A lot of people that we talk to have already heard about Ecodan. You know, they're a bit more of a household name these days, particularly when it comes to renewable technologies. We've touched on other products, and I have touched on the Mitsubishi Ecodans a few times, but I just really wanted to get a little bit more, give you a bit more information, let you kind of look at the equipment in more detail, just kind of give you an idea of, you know, why do we particularly install Mitsubishi Ecodan, for instance? You know, why do we choose this as one of our go-to products? And you know, hopefully this video will give you an idea as to why we do indeed go for the Ecodan. So listen up and we'll get straight to it. Okay, so people will ask the question, and it actually happened to me last week. One of our customers we're currently working on a project for. They said, why have you chosen Mitsubishi over something else for this particular install? And the same answer goes with all of our installs. And you might see from Instagram, Facebook, you know, we fit valence and Steebles, we fitted Kneebees. And Ecodan for this particular customer was the choice because we looked at the parameters and what we were trying to achieve and why it was a good you know, proposition for that home essentially. So the house is for a retrofit, and at the moment it's got radiators on all floors. Okay, so we've got ground floor, and we've got a first floor, and we've got a second floor. Ground floor, actually, from this point on, we're actually going to be putting in an on-floor heating system. We're going in for a routed in system, and the downstairs then will purely be underfloor heating, just leaving first floor with 3 bedrooms and a bathroom, and then a top floor which has got an added bedroom and another bathroom. And I said, well, look, we were looking at the space and, you know, what we had to offer and where we could place things. So they've used, or the house that they purchased, they've used the loft space for a room. Okay, so that eliminates some of the areas of space in which we could actually put a hot water cylinder. Now this is your typical package. Okay, this is what we would usually supply with a kind of a regular install. Okay, so it's a heat pump that's just one heat pump required, a hot water cylinder, and, you know, a moderately I'd say like a heating system that isn't, you know, isn't overwhelmed. It hasn't got millions of radiators, well, I say millions, but, you know, like 20, 30 radiators or anything like that. You know, this home's got about, in total, about 6 radiators and an underfloor heating system on the ground floor. The only space that they've got available for a cylinder is an airing cupboard. So we've looked at the size of the airing cupboard and what can we fit in there. Now, with many systems, unlike the Ecodan, a lot of the systems will require a buffer tank. If you've seen some of our other videos, and why we have to install buffer tanks to certain systems is that it will deal with and help with hydraulics. So, you know, balancing the system, making sure that we're getting equal flows into the heating system, and also that it will use some of that warmth or that hot water that's been stored in a vessel to come back and help with the defrost. Once these are really ramping up and we're getting some frost on the refrigerant pipework, it will withdraw some of that heat and it will help it to defrost. So with that in mind, and looking at that, looking at the airing cupboard, why we have chosen the Ecodan is purely that it enables us to use a smaller space for our install and makes our install slightly easier or less prohibitive. And a lot of our equipment here, this is what you'll end up getting if you have a pre-plumbed cylinder. And this isn't always the case. You know, there are installers out there, and we've done it as well, where this may not fit in someone's cupboard or an airing cupboard. So, you know, we've had to do what we call a third-party cylinder. So essentially you have a normal cylinder, or I say normal, it has to be heat pump ready. So it has to have a larger coil inside of the cylinder to enable it to be able to heat efficiently enough to give you appropriate hot water for a set amount of time. And then you'll get certain elements that will come with the package, i.e. this is the FTC, this is your control unit, this is the interface that basically will talk to the heat pump and a couple of other ancillaries. There's a flow sensor down here, and we'll look at this in more detail and go through it. There's a flow sensor, and then you'll need a thermostat, which will be a sensor that will go into the pocket of a cylinder to enable it to tell the heat pump, how much hot water is available inside the cylinder at that time, just so it can start producing and regenerating that hot water if necessary. The Ecodans also will come in several sizes. We get a 5 kilowatt, 6 kilowatt, 8.5 kilowatt, 11.2 kilowatt, all in a single fan unit. The only double fan unit is the 14 kilowatt Zubadan. So that's the biggest one that they do. It's a double fan. With that one, it's not under permitted development, so that would need to have application for planning, because the capacity of the refrigerant and its ability to deliver heat is slightly on the larger scale. Therefore, it doesn't quite fit into the realms of the planning development, permitted development for planning. The scops, they range, and we've got this coming up now. The scops will range from anything between, and we always vary this between a 45 degree flow temperature, which would be for your underfloor heating, and a 50-degree temperature, which would be for radiators usually. Now, we have done it on new builds, and we've installed heat pumps on new builds where we've reduced the flow temperature, because we found that it's more than enough to deal with, a house. It could be a neo-passive, so it's very, very tight and very, very well insulated, that in fact a 35, 37, 38 or 40 degree flow temperature is more than enough to supply very nice ambient heat across the entire property, and reaching that 20, 21 degree temperature in certain rooms, in what makes you feel comfortable. So the 8.5, for instance, at 45 degrees, it will give you a SCOP around about 4.1. At 50 degrees, the SCOP is 3.8. The 11.2 is very similar, but it's just under the 4 mark on the 45 degree temperatures. It's 3.9. And then when we get to 50 degrees, 3.6. On the much larger model, so the 14 kilowatt, you'll be looking at 45 degree temperatures about 3.7, 50 degrees about 3.5. And then when we get to the smaller units, so the 5s and the 6, we've fitted those in a few of the newer builds. So they're a smaller heat pump, more than capable of delivering a good heating and hot water demand. And they start ramping up. So, at 45 degrees on the 6 kilowatt, you're looking at just over 4 on the SCOP, and at 50 degrees, 3.8. So it's much less of much more efficient, I would say, especially if you're looking at a slightly higher temperature. Although in the new build, it's unlikely that you will need that high temperature. The 5 kilowatt, 45 degrees, you're looking at 3.9. And at 50 degrees, 3.56. So there's very, very marginal. So there's not huge differences and gaps within the SCOPs. We would then typically, so in the case of the installation that we're putting the Ecodan in that I mentioned earlier, what we'll end up doing, we're going to have underfloor heating downstairs. So that's going to be zoned, and it will have its own control. Each room will have its own control, and that will be a third-party control. We'll be using a heat miser, for instance, a wireless heat miser that has the capabilities of getting onto apps, etc. So you can use it via your mobile phones, etc., or laptop, tablets, whatever. Then we will have, if we've got a radiator system, which we will have, we'll use one of the Mitsubishi wireless controllers. Now, very, very simple to use. It will come up with a display which have temperature on it, and it will be an up and down to kind of select your temperature, and it will take a few seconds, signal to the heat pump, okay, I need heating coming on, and then it will be placed, I don't know, it could be on a landing, or more than likely a landing actually than a bedroom, because whatever room the thermostat sits in is what determines the temperature in which it will meet, and so it will give it a better balance. And TRVs obviously on radiators sized suitably for the rooms. If it's existing radiators, a power flush, making sure that system's clean and working as efficiently as it should do. You can actually get multiple zones of these receivers as well, so you can control more than one area, but we would look at the design and the property and just see what would work best. And then you might see here next to it, this is the basically the brains. This is the one that does all the talking. This is where we set things such as our heat curves and hot water temperatures, Legionella, which is your cycle, what they call pasteurization, whereby, you know, maybe once a week, once every 2 weeks, we'll get the temperature up to 62 degrees, have that sitting there for, you know, 3 hours or so, and then that gives it time to make sure that none of the bacteria can start forming from the Legionella. It's very rare, but it's, you know, particularly for new build situations and hot water that's being used all of the time, to get this Legionella, but it has to be in there. You know, we have to make sure that we eliminate any risk. The way that gets up to 62 degree temperature, the heat pump might take it up to 50, 55 degrees, whatever we've set it to. And then the internal immersion for this cylinder will then kick in, take it and bump it up to that other temperature, make sure it sits there, so it might come on and off a little bit if it starts to fall, or, you know, during that cycle you might end up using it. I mean, we tried to set the program in the middle of the night, but, you know, if it was in the daytime, or you might have, say, a tariff that works better on a Sunday afternoon, or you know, you might well have something linked up to a solar PV system, something around like that, then that will enable us to you know, control that, put the Legionella procedure on, and then that will sit there for the 3 hours in which, you know we can, you know, determine that the bacteria is eliminated. There are many features on this hot water cylinder, which is why we prefer to use it as the pre-plumbed for the install, because it's got a lot of the ancillaries and, you know, communication wise and sensors and everything's kind of already joined to this system that will talk to this heat pump and works very, very nicely. And we'll get to that, we'll look at that closer. As you can see, as I said, this going up to 11.2, this will be at this height in this range. And, you know, I think aesthetically it's one of the better looking machines as well. Ultra quiet, so, you know, the decibels on this will be around about 44, 45 decibels. So from a metre away, you really won't, you'll barely hear it. I mean, again, we've got videos going on online that you can check us out. You can check it out on YouTube or Instagram. You know, I've placed the camera on top of one of these units, and the unit is on, fully working, ramping up to provide hot water as we've just started it up. And I'm talking over it, and you can hear me. You wouldn't even realise it was on at the time. So check that out, and you can kind of get a measure of how quiet these machines now are. Uses an R32 refrigerant now, away from the R410A. Much more, well, in comparison to 410A, the R32 refrigerant is kinder to the planet. There's less global warming potential, and we've got some figures and some other data on another episode which you can check out. We'll put it at the end of the video. And because it's a slightly different refrigerant, it's much more efficient. There's less refrigerant required for the heat pump, and therefore as well it will reach up to temperatures using less energy. Yeah, so it makes it much more efficient for the unit to use. These units also come with the outdoor sensor is basically attached to the unit. Okay, so you know, with many other installations we would have, and I showed you on the last video, you know, for example, Valent or Nibi or whatever, they would have a separate outdoor sensor that you would have to find, you know, preferably on a north facing wall so it doesn't get direct sunlight. And that's obviously telling you, it's giving you a weather compensation, so it's telling you what the temperatures are outside, and it will talk to the heat pump. You know, does it have to kick in if it's dropping below a certain temperature? You know, how hard is it going to have to work if it's X outside compared to what it's like indoors? It's very, very clever in terms of how it will run. We often talk about drop-offs for certain units, okay? So drop-offs meaning that, you know, if something is, say, of an 11.2, at certain temperatures and dependent on the flow temperatures, some units will be able to perform at better levels. The Valent are an example for that, in terms of it can provide a larger heat capacity or kilowatt heatage output. Some of them, some heat pumps, I'm not talking about Mitsubishi, but some other manufacturers, you know, you might get, say, like a -2 or a -3 or a 0 degrees, And it might say it's an 8 kilowatt unit, but actually at that temperature, providing 50-degree heat flow temperature for a radiator, the performance level actually might drop off slightly. So where it was an 8 kilowatt, it might only be able to provide a 6.5 or 7 kilowatt heat output. Therefore, it's really struggling to maintain any heat in the house. It's working very hard, and then you're starting to see that it's going to be expensive to run, or you're not going to get the produced heat that you require, and start feeling slightly chilly in your home. Well, the Ecodans, the way they set them up and the way that these units will work, they are basically, on their data, they show that they're on a level playing field. So at -5, -3, -2, 0, 1, 2, if you've got an 11.2 and you need 11 kilowatts of heat output coming into your building, it will hit on that level and stay there. So that does provide some peace of mind, especially for us as installers, because we need our heat pumps to really perform, especially at the coldest times. What we don't want to be doing is putting something in and then kind of crossing fingers, and no one should ever do that as an installer, but just kind of hoping that it's going to be able to produce in the coldest of temperatures. We're confident that these work and that they will perform. We've installed them, we've had them in situations of very cold temperatures, and they have performed. If they don't, then it comes down to either a settings situation, or it could be just that it may have been miscalculated on the heat loss. But there's always a way, and it's really down to the installation that provides you with efficient and on point heat pumps that will provide you with heating and the hot water that you deserve. So these have been upgraded. They used to have an FTC5, which basically is their control unit. Since they've upgraded the refrigerant to an R32, they've upgraded the brains of the operation to what they call an FTC6. It just has, for us as installers, it gives us a few more options when it comes to setting things up and determining what's going on. The heat pump as well will come with a internet interface or Wi-Fi connection, and that will enable us to be able to work on this and look at this remotely. We can check out data, how much energy usage is being used, where's your hot water sat at the moment, why is it not coming on at said times, have you set up the programs right, have we set up the heat curve properly. We get lots of information and data that can be passed straight onto Mitsubishi, and that will give them the opportunity to then kind of gauge as to what could be tweaked, if anything needs to be tweaking, to give you ultimate performance. So that's speaking about the heat pump. We can have a very quick look inside of this one, just to kind of give you a look inside of what the working mechanisms are and why it does what it does. And then I think we'll just jump straight into what this cylinder does, how it's designed, and why we are able to use this as without a buffer tank, as opposed to some systems that do require that for their defrosts. Okay, so the pre-plumbed cylinder. This comes with most of the ancillaries in which you are going to require for your heating system. Generally, the way we rig these up, or what we can do with these, is put them on up to 2 zones. Okay, so what that means is that, as I've said in many instances, you might have downstairs, which has got underfloor heating, and your upstairs are radiators. Now, on the side of this heat pump, we've got what we call a low loss header. This helps with the hydraulics of the system, enables us to put connections on for another flow and a return. Additional to this, we would have to add a pump, for example, to circulate the water to said zone. And the capacity of what this enables us to do on the hot water side is one of the reasons why we are able to use this system without necessarily putting in a buffer tank, should the system allow for it. Now, if it's a fairly large heating system, we would recommend putting a buffer tank in, but I think that just comes down to what we look at and how we would design the system. So this one typically comes as so that you could attach, say, one zone on it. So if we've got, say, a down, like a bungalow or something, you know, we could put on one zone here that would take it to a manifold or a radiator or something, or maybe an underfloor heating system or some radiators on the downstairs. And we take off a flow from this. This pump here is actually your heating flow, which will take the flow from the heat pump into the heating systems, returns it back here, takes it through the pipe work, which then goes through the return back to the heat pump. We've got a large pump here. This is the one that draws the heat from the, or delivers the heat from the heat pump and back in its flow and return ratio. This is just a simple diverter valve. So our hot water incoming from the heat pump, and then it will either go into a hot water mode or it'll come around and supply the heat in. Never does both. Now on older systems or conventional systems, you have what we call like a 3-port valve, but it's a mid-position valve. So that would mean that you can either have heating or hot water, or you can have heating and hot water. Whereas this will always, and heat pumps will always prioritise doing one job at a time. So it will prioritise your hot water, and once it's satisfied, or if the cycle is very, say it's very cold outside and you want to maintain a temperature indoors, what it would do, you can set these parameters up, but you could say, I want you to generate hot water for an hour, then come off for half an hour, keep doing the heating, come back on again until we get to our said temperature that we've set on our control. So it's very clever in a way in which it does that. Or we can just say, look, just give us all the hot water first, then go into heating mode. But that's, again, down to the installer to kind of set these parameters up. Then on the front of here as well, so coming here, we've got obviously a filter, magnetic filter. This just really enables us to you know, keep the system efficient and clean from any debris, particularly, you know, kind of radiators that, you know, might want to go in, you know, magnetite and stuff like that. But I mean, if everything's inhibited properly or protected properly, shouldn't really have too much of an issue. But this will just pick up any kind of small debris or any shards of, you know, inside of radiators or whatever. That helps protect it. On here we've got a heat exchanger. Now a conventional, I'd say, hot water cylinder, if you're using what we call indirect, so if you're using a heat source, whether it be a boiler or a heat pump, generally you'd have a coil that is going round in a big spiral inside the cylinder, and that is what's getting heated up, a bit like a radiator, gets heated up and it heats that hot water inside. Now, this uses a slightly different technique, very similar to, I'd say, probably like a thermal store type situation. It's not a thermal store, but what it does is it has a heat exchanger here. The hot water is generated from the heat pump, will cycle in, it will go through this heat exchanger, and on this side is going to be from your medium, your heat pump, and the other side will get put into the hot water cylinder and come back out. So basically what it's doing is actually using this pump here to pull the water through this heat exchanger, very similar to, like, say, a combi boiler. That's how a combi works. You know, your hot water is generated by a heat exchanger inside, and then it will flip through and it will give you hot water. But this is doing the same thing, but you're actually getting stored hot water in a hot water cylinder. So there's no actual coil in there at all. As it passes through this pump and comes through and back through this heat exchanger, all the water passes through this patented scale inhibitor or reducer, and inside of this vessel here, you're just protecting the cylinder from scaling, from lime scale. So, you know, the longevity of the cylinder itself is prolonged significantly through this technology. So obviously, you know, you must make sure that we've got both of these in the on position when, you know, going through the motions of putting your hot water on. And yeah, I mean, that's basically what you'll get. And that means that your capacity inside of the cylinder is the capacity of hot water that you're getting. And what I mean by that is that when you put a coil in there, it's going to take up some room. So you might have something that, say, I don't know, 210 litres, but with a coil inside, you only actually might get about 185 litres of hot water in there. So, you know, this actually truly gives you the hot water demand in which, you know, or the hot water that is inside is what it is. 210 litres would be 200, but this is 250. But then attached, so all of our gubbins and everything are controlled here. We've got various sensors, one telling you what the flow temperatures are, one's telling you what the cylinder temperature is. And on the newer ones, they've actually got two thermostats or thermistors, which will one will be a higher, one will be slightly lower. You've got different controls, so that it means that, you know, you can either have like a normal hot water mode, whereby it will read off of one thermostat and give you your hot water at said temperature, or you would have a larger capacity and you can add that into your cylinder. So you've got quite a high hot water demand at home. If you've got a large family or a few bathrooms that go off and everyone's kind of sharing at the same time, you've got a larger capacity, which means that it will heat up and read off of two thermistors, making sure that you're getting real, you know, it's going to be slightly more in terms of its charge time and how much energy it's going to use in terms of generating that hot water, but it will make sure that it fills up a larger capacity of this with true hot water. So at said temperature down at this level, if it's say 50 degrees, you get stratification, and as it gets higher up into the cylinder, hot water obviously rises or heat rises, and it could be 53, 54 degrees the higher you get in the cylinder. I mentioned about Wi-Fi, you know, using an internet connection. Well, this is installed on the heat pump. You just have to do your connections from the interface, the connections from this to your Wi-Fi signal. Can be done very, very simply. You've got a mode button, you hold it in for a few seconds, you start getting a number of lights that are coming into sequence, which, you know, which would be explained or set up from your installer. Then you go to your router. You can WPS a system or press a button and it will read and quickly pair. Once you've done that, it gives you instructions of how to get onto an app, the MailCloud app, which will enable you then to get on and look at some of the control in which you can do on your phone. And I've got a few little pictures of, you know, what that looks like on your phone, and we'll do a few tutorials as to how easy or how difficult it may be for you to use, but I think it's very easy and simple, and you don't really need to get too technical with it. So that pretty much sums up, you know, what we've got here, and we've got various other things that are capped here, which, you know, we do links to expansion vessels, and we've got connections for the cold water to make sure we've got all the right pressure relief valves, etc. on, and, you know, it works really very well. And, you know, when you've got this kind of setup already linked in with the heat pump, you really got a good, you know, the install makes life far more you know, easier, you know, and making sure that you've got everything set up. And with this confined onto the cylinder, if you've got a certain said space to be able to use, at least you can get all of this on that one in that kind of tighter space, so you can utilize that space a bit better. Typically this is a standard unit, okay, so this will need a floor area of at least, you know, 800 by 800 mil, and then that will, you know, allow us enough room, and everything being at the front is serviceable. There is a slim line, but that only comes in two sizes, and, you know, that's only up to about 170 litres. And there is also solar ready, and we've fitted one with a solar panel with solar thermal jointed into a second coil, and, you know, again, just works wonderfully well. If you've got solar thermal, particularly on days like today, it's very hot outside today, we've got loads and loads of sunlight. From 5 in the morning it starts to get light, but, you know, you've got from, I don't know, say probably, yeah, about 5:30, 6 o'clock, you've got daylight right up until 9 o'clock in the evening. You know, in the summertime, when you've got those kind of things, you're generating more hot water than you require, and you won't even need the heat pump to set in. So there's lots of advantages, and there are ways in which these can be rigged up to do so. So that is our cylinder. Okay, so the heat pump itself, I mean, I've just taken off the lid and everything to kind of give you a kind of look as to, you know, what goes on inside of that heat pump. There's a lot of wiring, a lot of PCB control, and then this element of it here. Again, basically, this is all of your refrigerant pipework going through here. The job of the fan is to pull the warm air through into the back of this. It all gets sucked through. Then the refrigerant and all of these fins just increase the capacity of how much energy can be withdrawn from the air. It picks up, picks up the temperature of the air, takes out whatever energy it can, even at -2, -3, -4, -5, and even up to -10. It withdraws any energy that it can. It will convert that energy from this refrigerant pipework into a compressor, and that will do all of the job in which to convert that energy into useful energy. So the refrigerant gases will work from a liquid to a gas, generating high temperature, passing through a heat exchanger inside of here, which will then generate the hot water that we need to get into the home. So the fan's job then is pulling that energy out. If you ever stand in front of an air source heat pump, and when you install one, you probably will, you'll feel that the temperature is a lot colder in front of that fan than it is away from it. And the ambient temperatures coming through can be between 10 and 15 degrees lower as it pulls out through here. So if we're 15 degrees behind, you know, we could be as low as 0 degrees in front. So, you know, it's really using as much energy as it possibly can out of the air to generate the hot water we need for the home via the radiators and the hot water circuit. Just here, I mean, for many of us, most of the connection and points of the electricals will literally be at this point here. We've got your live feed in. So this is going to come from your rotary isolator that will be on the outside. Depending on the size of the heat pump, depends on how many amps you're going to need and what voltage is going to be required. Well, the voltage will stay the same, but it's the ampage. That will be connected here. Then we've got this. This is S1, S2 and S3. These are basically your signal cables, and they will go onto the or inside of the interface in here. So there's a very similar computer electronics inside of here. And what that will do then, it will take it and give power, then it will give signal, and basically it will talk to each other from whatever distance. We generally put in a 4-core cable, which allows us to go to earth, power and signals, and then the same on the inside of the unit. That's all we really need to be worried about as installers, really. That's all we should be worried about. Now, in here, on the 11.2s, this is an 8.5, so it's not really going to count. But inside of here, around the computer, you have to, around the compressor, you have to take these off, this packaging off, because inside there is going to be the travel safety bits in there, which would be polystyrene stuff to stop anything moving about too much, and it's bolted down and stuff. So you read the instructions, make sure that you do remove the packaging that's inside of this part here, because if you don't, when that heat pump is running, it will be whistling and blowing, and there'll be a lot of noise coming from it. And often you'll be like, I thought this system was meant to be quiet. If you find that it's noisy and you've got 11.2, there is a very good chance that the packaging on the inside, the travel packaging, hasn't been removed. Also, you'll find on the R32s, this is new on the heat pumps. This is a pressure relief valve for the refrigerant. So if anything ever over-pressurizing the refrigerant, that needs to be connected to make sure that that will allow a disperse should anything happen out of the ordinary. It's very, very, very rare, but again, it's another safety mechanism to consider. I mean, this is sat on the pallet now because it's just packaged, ready to go onto one of our jobs in the next week or so. But generally, you'd have anti-vibration feet, very similar to what you've probably seen on other videos. And they will sit on the anti-vibration feet just to stop anything from, you know, rattling around too much on the ground. It doesn't really rattle or anything like that at all, but you've got to imagine you've got a fan here, you've got working components, so you need something just to absorb any kind of movement or internal vibrations, just to keep everything nice and quiet. The connections for the hot water, or the primaries as we call them, simple here and here. They will come with flexible hoses, or you order them with the heat pump. We tend to normally go for ones that have got elbowed flexes on them. That's just purely because we end up putting this very close to a wall generally, and then we have somewhere that we can then obviously connect onto, and we'll bring our primaries out and we have to make sure everything's very well insulated. But the connection on the outside is very simple. And that's just your outdoor sensor. That's what's telling us what's going on outside for the temperature, so it can use its weather compensation. And that is generally the anatomy for the heat pump. You will also, actually, I'll point out, there's a couple of holes right at the very back there. If it focuses in, we will connect a condense drain to that. So basically, when you're all that pipe work at the back there gets very, very cold, it starts to form a little bit of ice around it. When it gets to a certain temperature, then the heat pump then has to go into a defrost. When it starts to defrost, it basically draws the heat back in through the refrigerant gas and through that heat pump, or through the refrigerant tubes. It gives it a chance to melt the ice that would be formed. It shouldn't be a huge amount, but what it will do in the winter time, it will be more prominent, and then that will need to drain away, and then we put that to a drain or a little soak away. You can have a shingle base underneath that will allow the water to run away. Just to point that out too. So there you have it, ladies and gentlemen, the Mitsubishi Ecodan. I think we've pretty much covered everything that we need to cover when it comes to what to expect from your heat pump and cylinder arrangement. This is your typical kind of package that you would receive, I would say. And again, there's so many different variables that, some things might need to be tweaked and some things might change, but it kind of gives you a general idea of what you'd expect when it comes to having an install done. The product's brilliant. I mean, as I've said, market leading and speaks for itself. Customer service is excellent. There's 5-year warranties available. Technically, if we ever need any help, and we talk to the technical guys over there, there's no question that's too stupid or difficult or too small to answer. They're very attentive to what we need as well, so we get the support in which we need, and we're very confident in the product. We know that it works very well. We've had great feedback so far, and people have generally had a very harmonious situation with their heat pumps when we've installed these. Again, versatility as well. There's no kind of restrictions as such because of the refrigerant, for instance, that stops you from placing it in certain positions of the house. If you look at some of our other videos, there are certain parameters that we have to consider when it comes to doors, windows, or drains, etc. This here, its ability to be able to be put, under a kitchen window or something like that is not a problem. And also, we can use wall brackets as well, so we can hang heat pumps if we need to, if you didn't want them too much on the floor. We've done that before. And yeah, like I say, just a great product. Thank you very much for watching. Please like the channel, subscribe to the channel, put comments in on the video as well if you can. Any feedback is always generally pretty good for us. It gives us an opportunity to make sure that we're giving you the content that you wish to watch. If you've got any questions, please let us know. Make it aware in the comments. You can contact us via our website, www.dorewoodman.co.uk. Available on Instagram @dore.woodman, and also you'll find a Facebook page as well, which literally is just finding Dore Woodman on there, and you'll find us, and we'd be happy to have you on board and kind of showing you some of the installs that we've got. We've got various videos out there, pictures, stuff to do with our other engineers out on site and stuff. So it's quite interactive, gives you an opportunity to see what we're about as a business and what to expect from heat pumps. Thanks again for watching. Can't wait to do and speak to you on the next video. Thank you.